Hey guys, welcome back. We are going to be doing product except self. Okay, product of array except self, and this is a medium difficulty problem. Okay, so given an array, an integer array nums, return an array answer such that answer at I is equal to the product of all the elements of that array except the number that you're on. Okay, the product of any prefix or suffix of nums is guaranteed to fit into a 32-bit integer. So that's pretty interesting. You don't have to worry about overflow or anything like that. You can just deal with ints, and you're running your running product could just be an int, and you don't have to worry about longs or anything like that. You must write an algorithm that runs in O of n time and without using the division operator. Okay, so the division operator would be very simple. Basically, we could get the product of every element in the array and just divide it by the current number. And that would guarantee that we would have the product except the self. So that's one way of doing it. But if you're in an interview, it would pass. It would pass here. But if you're in an interview, they'd said, well, that was one of the preconditions was you can't use the division operator. So we're going to have to figure out a way of doing this without the division operator. So let's look at this. Here's an example. So we have 1, 2, 3, 4. And so we are going to return the array, but changed in a way so that it becomes this. In this ones place, we have the product of all the other numbers in that array. So on this one, we have 2 times 2, 3 times 4, which is 24. And then in this 2, we have 1 times 3 times 4, which is 12. And then in this 3, we have 1 times 2 times 4, which is 8. And then in this final 4 spot, we have 1 times 2 times 3. And that's going to get us 6. Okay, so what we want to do here is we want to loop through this array multiple times. Okay, we want to loop through the array multiple times, and then we're going to take, so we got 2 passes. The first pass is, so we're going to be looking at it in this direction. And then in the second pass, we're going to be looking at it in this direction. Okay. And now, why do that? All right. Because if we're right here, we need 2 groups of numbers. So in order to get the product of all the elements except 3, we need the group of numbers before 3, and we need the group of numbers after 3. Okay. So what we want to do is we want to take a pass this way and set the product of all these right here. And then we need to take a pass this way and multiply the product that we had saved in the first pass by all the numbers that came after it. Okay. So what we're going to do is, so we're going to start by saying we have a running product. Okay, so right here, our running product is going to be equal to 1. All right, and so, okay, so we do want to keep this array intact. And so we don't want to change that. And so we want to create an array that we're going to return, and we'll call that our output array. Okay, so right now our output array is complete. All right, but what if it were not? So right now we could imagine an output array and it would have 1, 1, 1, 1. All right, and so how are we going to do this? All right, well, we're going to have a variable, and we'll just call it running product. and we're going to set it equal to 1. And so what we're going to do is we're going to loop through our nums array. So num in nums. And then what are we going to do? Well, we're going to say output at I is going to be equal to our running product. Okay, so whatever that running product is. And then what we're going to do is we're going to say running product, so whatever our product is, times equals nums at I. Now I know this is a for each loop and we're using the I iterator right here. But you get the idea, okay? And so right now, if we're to run through using that kind of logic, our running product would start off as 1. And then we're going to say, well, output at I, which is right here, output at I is going to be equal to this 1. And it already is, but let's just say that we're setting it equal to this 1. Okay? And then we're going to multiply. We're going to take our product, which is our running product, which is 1, and multiply it by nums at I. Well, that still stays 1. Okay? And so right here, it is going to be 1 as well. And then we're going to take, in this spot, we're going to take output at I is equal to product. So this becomes 1 as well. Right here, this becomes 1 as well. And then we take, for our running product, we're going to say, well, we want to multiply it by nums at I. And so for us, that's a 2. And so running product becomes 2. And then in this 3 spot, we're going to say output at I is equal to whatever the running product is. And so this becomes 2. And then we are going to say, well, 2 times 3 is going to be now the new running product, and that's going to be 6. Okay, and then we get to this 4, and this nums at I right here becomes the running product, and then this becomes 24, but it doesn't matter. We are at the end of the array. Okay, so in this pass, so first pass, we have 1, 1, 2, 6. And then in the second pass, what we're going to do is we're going to reset. Okay, so we're going to reset our running product, and then we're going to go in the opposite direction. So right here, we'll just say backwards. Okay, the opposite direction. Okay, so we're starting at this. Okay, so we'll assume I is length minus 1. Okay, and so at 4, what we're going to do is we're going to say, well, we're going to take our running product and multiply it by this 4. Okay, I'm sorry. We're going to take our running product and multiply the output array by our current running product, which is 1. All right. And then we're going to say 1 times 4 is now our new running product. And then we're going to take our running product here, and we're going to, so this becomes 4. Wait. This becomes 6. Let me just back that up. Okay, so this becomes 6. And then now this is 4. And what we're going to do is we're going to say output at I is equal to product. So, but on this pass, we don't do that. What we do is we do times equals product, okay? So 1 times 6 gives us 6. And then now our running product becomes our product times nums at I. And so nums at I is 1 times 4. And so what we want to do now is we have this 2 in this first pass. And so this 2 times our product is now 8. Okay, and then we have, and then we do running product times nums at I. Well, we're already there. Okay, so product times nums at I is 3, and so this becomes 12. Okay, and then what we do is we take this 12 and we multiply it by this running product here, or by this first pass. And then we say, well, then we say product times equals nums at I. Well, nums at I is 2 in this position. So we take our 12, multiply it by the 2, and we get our 24. Now output at I in the first element is going to be equal to times equals the product. So 1 times 24 gives us 24 here. And then, well, we don't care about this step. We're just going to multiply it by whatever. But this second pass gives us the answer, and then we can just return the second pass at that point. Okay, so we are essentially creating a new array, which is the output array. So this is our new array, and we're taking 2 passes. So 2n would give us O of n time complexity. And then we have our 1 output array, which for memory, that would be O of n as well. Okay, so let's go ahead and get to the example, or to the actual problem. Okay, so like I said, we need to create our output array. And so we're just going to do that. And it's going to be the same length as nums. And then we have that running product. And then we're going to loop through our first time. And then I++. And then so what we said was, we said output at I is going to equal our running product. Oop. And then what we're going to do is we're going to take our running product and times equals nums at I. Okay, perfect. And then what we're going to do is we're going to reset our running product. So I'm just going to copy paste. And then we're going to work backwards. Okay, so we're going to say for int I is equal to nums dot length minus 1. I is greater than or equal to 0. I minus minus. And then we're going to say output at I times equals running product. And then we're going to say running product times equals nums at I. Okay, so that gets us our output array. And we are just going to return output at that point. Okay, so let's go ahead and run our code, make sure that we have no typos. Looks good. And let's submit this. All right. So here we go. We have faster than 100% of Java submissions. That means nothing. I am doing this pretty late. It just so happens that maybe the server was not fully taxed. And so, but this is pretty good. Okay, so this is obviously an optimal answer. And if we look at the description, it runs in O of n time with memory O of n as well. And so we fulfill the requirements. If you found this video useful, then go ahead and like and subscribe. It costs you nothing to like a video. Please subscribe. It helps the channel grow. It helps me maintain the motivation to make these videos because I'm understanding the problems. I'm doing the problems on my own. But to make the videos, it's an extra, 30 minutes of my time for each video. And so when I see those subscribers and the likes and the comments, then I'm like, yeah, some other people need this too. So if that's you, just go ahead and do that. But otherwise, I will see you in our quest to conquer the Grind 75 and to get in at a top tech company. See you later.